to respected madams and sir. This is Pavan Sai from CSM of section C. So today the topic I choose is applications of object-oriented programming techniques in the study of wave scattering. So what is object-oriented program? Object-oriented programming, also known as OOPS, is a concept which helps creating real-like objects by using programming. For example, we can say a car which has a specific color, specific speed, specific make. So let's get into the concept. So the concept, the first concept is applications of object-oriented programming in the study of wave scattering. So here we can see there's an image of wave, and it shows that the object-oriented programming is a power paradigm that has a revolutionized software development. OOPS key concept such as encapsulation, inheritance, polymorphism, and offers specific benefits in tracking complex computing problems like wave scattering. So, introduction of wave scattering. So, first one, wave interaction. Wave refers to the phenomena where waves interact with objects or inhomogenized, causing their deviations from their original path. And divisor application. It plays a crucial role in various specifying and engineering disciplines, including accountism and optics and geophysics. And the third one, key focus. This presentation explores how OOPS techniques and enhances our understanding and analysis of wave scattering phenomena. So, fundamental of wave scattering theory. Waves, wave equation. The governing equation that describes the behavior of wave in a given medium is known as the wave equation. And the second one, scattering boundary conditions. And the third one, scattering solution. Finding the scattering solution involves solving the wave's equation subject to the specific boundaries conditions. The traditional approaches of wave scattering analysis. There are three types: analytical method, numerical method, and experimental techniques. When it comes to analytical methods, these methods involve in deriving mathematical expressions and to represent the scattering solution. The numeric methods, which also shows that numeric methods such as finite elements analysis or finite difference time domain approximates the solution using discrete steps. This can also take in many more examples, but I choose three examples. And the third one, experimental technique. Experiments involve physical measuring and analysis scattering waves controlled in the settings. Limitations of traditional approaches. There are three limitations. So complexity and computational cost, experimental challenges. These three indicates the limitations of traditional approaches. The first one, complexity. Analytical methods can be becoming very complex for realistic scenarios involving multiple scattering of objects. And the second one, computation cost. Numerical methods often require significant computational resources, limiting their applicability to large scale problems. And the third one, experimental challenges. Experimental challenges. Also, experiments can be expensive and time consuming, may feasible for all types of scattering problems. And the object concepts of object oriented programming. The first one, there are actually five concepts. So, encapsulation, the bundle data methods within object promoting modular and data protection. Also, encapsulation is also known for hmm, it is a fundamental concept in object oriented programming that refers to Bundling data variables and methods functional the operators on the data in single unit typical. A class is also restricted direct access to some of the object's components to ensure the control interaction enhancing security and modular. And the second one, inheritance. uh, Inheritance allows to create new classes that inherits properties and methods from existing classes. Classes promoting code reusability. Inheritance is also another core concept of object-oriented programming that allows one class, which is also called child class or subclass. It inherits properties from its another class, also known as parent or superclass. It promotes codes. It promotes code reusability and establishes a relation between classes. And the third one, polymorphism, is an it enables objects different classes uh, to respond the same message in enhancing flexibility and extensibility. Polymorphism, it is also a fundamental concept of OOPS that allows objects to take in multiple forms. It enables a single interface to represent different type of classes, making it possible to call the same method or different objects and achieve different behaviors. And the fourth one, abstraction. Abstraction in object-oriented programming that focuses and hides the implementation default details and shows only the essential features of an object or system. It helps to develop focus on what an object does rather and how it does. These are the four concepts of OOPS. So the advantages of object-oriented programming approaches in wave scattering. The first one, modular and reusability. OOPS promotes codes modular, allowing for for developers maintain and reuse of the code. It also provide better security than other programs and flexibility and extensionability. OOPS concept. This concept allows for more flexible and extensible code, makes it easy to adapt to new scenarios and requirements. Data abstraction. OOPS provide a level of abstraction that simplifies the representation of complex scattering phenomena. And the OOPS benefit of modular and reusability. Classes can represent components like waves, materials, or scattering, spheres, planes, cylinders. These three are the examples. These classes can be reused in different scattering scenarios or simulations. Modification in one class, example material properties, do not affect the rest of the code. And when it comes to flexible and extensibility benefits, abstraction classes or interfaces can define high level behavior. Example, solve boundary conditions. Specialized classes implements the abstraction for specific waves types. Example, acoustic, electromagnetic. User work with simplified interface rather than solving equations manually. uh, and the third one, data abstraction benefits. Polymorphism allows the same interface, calculation scattering, to be implemented differently for the variation waves types of uh, scattering geometric. This makes this system extensible for new waves types or geometric without alternating existing code. And encapsulation keeps the parameter and their behavior bundled in single class, ensuring data integrity and clarity, enabling easy modifications or extensions or of specific behavior without affecting unrelated parts of the system. And hierarchy class structure allows simulation that to scale up. For example, compensate scatter classes can be managed multiple scatter objects and interaction, enhancing maintaining and reusability for large system. Classes can classes can encapsulate numbers solving example for different equations, integrated them seamlessly into wave scattering systems. Libraries like NumPy, SkyPy, or MATLAB are easily interfered. So The module sound waves interaction with barriers or materials, also known as acoustics. Electromagnetic scattering simulates radars, waves, or optical light scattering. Semisonic scattering, understanding wave interaction. Aerospace, evaluating radars cross section RCS for stealth technology. These are the real world applications of OOPS in wave scattering. So implementation of OOPS, object oriented techniques. The first one, wave object. It represents waves as objects and encapsulates their property, amplitude, frequencies, etc. and behavior. Uh, and the examples, propagation, scattering objects. Modeling scattering objects are as objects allows for defining their interaction with waves and generalizing scattering patterns. Simulation environments, creating a simulation environment using OOPS allows the organize and manage them between waves and scaling objects. The cases studied and applications, radar system and medical ultrasound, semic exploration, and these are also used in CT scanners, which helps to scan a human body. And the first example, radar system. OOPS helps modular radar signals and their interactions with targets objects for accurating objects detection and tracking. This is also used in aeroplanes and fighter jets to detect another plane or another object in by using radars or ultrasonic waves. Medical ultrasonic. This allows for accurate representation of sound waves and their interaction with tissues, enabling non-invasive medical images and diagnostics. These are used to check the bone structure of a human being or the internal components by using ultrasounds. Semic exploration. Uh, this is basically here we can see you faculties modeling of waves and their properties, earth layers and entering oil and gas deposition, which is used to check the resources in the earth. Consultation and future directions. Object oriented programming involves in a very powerful framework for tracing complex wave scattering problems. Its advantages in modular flexibility, diverse fields, and data abstractions make it valuable tools for researchers and engineering. Future researchers can focus on existing OOPS applications to address emerging challenges in the area like materials and wave manipulations. So, thank you. This is my presentation.